Good morning, students. Today I am going to start new chapter, atoms. So first you see the J.J. Thomson model. J.J. Thomson model. According to this model, all positive charge are uniformly distributed over the volume of an atom, and negatively charged are embedded in it, just like seeds of water. So according to this model, all positive charge is uniformly distributed over the volume of an atom, and negative charge are embedded in it, like seeds in watermelon. Means according to this model, all positive charge is uniformly distributed over the volume of an atom, and negative charge are embedded in it, like seeds in watermelon. That is, seeds just behaves as a electron. Now, so according to this model, the electron is not fixed, okay, and positive charge is also not fixed, or there is no definite conditions of nucleus, where is the nucleus exists. So according to Rutherford model, according to this model, भाई कैसे कैंसिल कर दिया। According to this model, all positive charge lie in a very small volume inside the atom is called nucleus. Now, so J.J. Thomson model, according to this model, all positive charge is uniformly distributed over the volume of an atom, and negative charge are embedded in it, like seeds in watermelon. And Rutherford model, according to this model, positive charge lie in a very small volume inside the atom is called nucleus. In different orbits. Now next topic, Geiger-Marsden experiment.
हाँ जैसे जब खत्म हो गया लास्ट में, मैंने कहीं रिकॉर्ड में जो लास्ट में सब आशीष सबसे कोई नहीं किया, तो यहाँ पर से 18 में कहीं कॉल में
Geiger Marchandise experiment. This is the
नहीं चल रहा था भैया, मैं नेट नहीं प्रॉब्लम, नेट पूरा बंद होता तो
source of alpha particle. This is slit.
पब्लिक है सर, वो हटा दो ना, वो पहले रहा और डिलीट कर
Slit.
हाँ, तो जरा मुझे बता, जैसे मान लो कि कोई टीचर बोला कि अच्छा इसको फिर से चलाना, तो वो कैसे?
This is thin gold foil.
जैसे कोई टीचर बोल रहे हैं ये खराब हो गया, इसको हटा दो, दूसरा चलाना, तो वो हटाना कैसे है ये बता दो।
Thin gold foil. Its thickness is about 2.1 10 power minus 7 meter, and this is a screen. So this is alpha particle produces from this source and it moves incident on the thin gold foil. This is detector. और माइक्रोस्कोप, backward scattering of alpha particle that is 1 in about 8,000. So Geiger Marchandise experiment, this is the source of alpha particle, this is slit, this is thin gold foil, and this is the screen, and this screen is polished, that is zinc sulfide. So when the alpha particle moves pass through this slit, first it incident on the thin gold foil. This arrow shows the most of the alpha particle pass through state without any deviation, and some alpha particles deflected at an angle theta on the screen, and the detector measures the intensity of this alpha particle, and this alpha particle give the signs on this screen, which is polished by the zinc sulfide, and 1 in about 8,000. This arrow shows the 1 in about 8,000 alpha particle retrace their path. So following observations about this experiment, observations about this experiment. First point, most of the alpha particle were found to pass. Most of the alpha particle were found to pass through the gold foil, through the gold foil, through the gold foil without deflection, without deflection. So this is the most of the alpha particle were found to pass through the gold foil without deflection. Second point, in passing through the gold foil, in passing through the gold foil, in passing through the gold foil for different alpha particles, for different alpha particles underwent different angles of underwent at different angles of deflection, angles of deflection. So in passing through the gold foil, this rays show this property. In passing through the gold foil for different alpha particle, this is for different alpha particles underwent at different angles of deflection, underwent at different angles of deflection. So this rays show this property. In passing through the gold foil for different alpha particles underwent at different angles of deflection. Now the next property, third point, this is now the third point. 1 in about 8,000 retrace their path. 1 in about 8,000 alpha particle backward scattering or retrace their path. 1 in about 8,000 alpha particle retraced their path means one alpha particles, about 8,000 alpha particles retrace their path means backward or deflect through pi angle. Now if we plot the graph, number of scattered, graph the plot total number of alpha particle scattered, the graph plotted between total number of alpha particles scattered total number of alpha particles scattered through angle theta, and the scattering angle theta, and the scattering angle theta are given below, given in figure or as shown in figure. So here we will plot the graph between total number of scattered alpha particles, through angle theta. This is total number of alpha particle scattered through angle theta, and this is scattering angle theta. This is scattering angle theta. So the nature of graph will be like this. It means when the angle of scattering angle will increases, so total number of alpha particles scattered decreases, and when theta decreases, then total number of alpha particle scattered increases. It means at a small angle, that is the large number of alpha particles scattered or passing through state, and at a greater angle, a few alpha particles scattered means bent their path. Now the electrostatic force between the alpha particle, the electrostatic force between repulsive force between alpha particle and charge of nucleus. The electrostatics repulsive force between alpha particle and nucleus, charge of nucleus, alpha particle and charge of nucleus F equal to 1 by 4 pi epsilon naught into 2E ZE upon R square, where 2E this is the charge of alpha particle, ZE this is the charge of nucleus, R where R is the distance between the alpha particle and nucleus. Now alpha particle trajectory. Next topic will be alpha particle trajectory. Alpha particle trajectory. Alpha particle trajectory. This is positive nucleus, this is positive nucleus, this is alpha particle, and some of alpha particles deflected at angle theta So with the help of this figure I am showing here alpha particle trajectory. Some of the alpha particle means that is 1 in about 8,000 alpha particle retrace their path, that is pi degree. When it strike to the nucleus, then it reflect back and follows the same path, that is, and some alpha particles deflected through an angle theta. So with the help of this figure, this is the distance of closest approach. This is D. This D shows the distance of closest approach. This when initial kinetic energy of alpha particle, or we can say that the alpha particle moves with initial kinetic energy, and when it reaches at this point, so due to strong repulsive force between the alpha particle and nucleus, it reaches their path. So the closest distance of closest approach, the minimum distance from the center of nucleus, the minimum distance from the center of nucleus to the point where the kinetic energy totally converted into potential energy, where the kinetic energy converted into potential energy, and this alpha particle retrace their path. So, and this is impact parameter. This B shows the impact parameter. Impact parameter is defined as the perpendicular distance between the center of nucleus to the point where the alpha particle deflected through an angle theta from initial path. Clear? So first, with the help of this figure, first we will explain impact parameter. Impact parameter, it is denoted by B. This parameter, impact parameter, denoted by B. The perpendicular distance, distance between center of nucleus and the point from where the alpha particle deflected is known as impact parameter. So the perpendicular distance, this is the perpendicular distance between center of nucleus. This is center of nucleus. This line shows the center of nucleus, and this is to the point from where alpha particle deflected. This is known as impact parameter. For theta equal to 0, for theta equal to 0, it gives the size of an atom, means it gives the size of an atom. So for theta equal to 0, impact parameter gives the size of atom. For theta equal to pi, impact parameter theta pi means this is theta pi. So this parameter shows the size of nucleus. For theta equal to pi, impact parameter shows the nucleus size. Now distance of closest approach, this is the distance of closest approach, the minimum distance from center of nucleus to the point where the alpha particle retrace their path, or you can say that the initial kinetic energy of alpha particle converted into the electrostatic potential energy. So distance of closest approach, distance of closest approach, the minimum distance the minimum distance between center of nucleus to the point from where the alpha particle retrace their path is known as distance of closest approach. It is denoted by D. It is denoted by symbol D. Now calculate the distance of closest approach with the help of this figure. This is initial kinetic energy. Initial kinetic energy is given to the alpha particle, and when this alpha particle reaches at this point, so this total kinetic energy converted into electrostatic potential energy. It means nucleus is solid and the force between this alpha particle and this nucleus, it is potential energy. So due to strong repulsive force, this initial kinetic energy converted into the potential energy. So the kinetic energy is equal to potential energy between nucleus and the alpha particle. This is potential energy. So this kinetic energy K equal to, now the potential energy between alpha particle and nucleus, 1 upon 4 pi epsilon naught 2E and ZE upon D. So with the help of this formula we can calculate the value of distance of closest approach. D equal to 1 by 4 pi epsilon naught to ZE square upon K. K is kinetic energy. This is, so with the help of this formula we can calculate the value of distance of closest approach. Once again you see the distance of closest approach. The minimum distance from the center of nucleus to the point where the alpha particle retrace their path, this is known as distance of closest approach, and in this process total initial kinetic energy converted into electrostatic potential energy. So this kinetic energy equal to potential energy, that is K equal to 1 by 4 pi epsilon naught 2E into ZD upon D. So D equal to 1 by 4 pi epsilon naught 2 ZD square upon kinetic energy, and already you know the value of this constant 1 by 4 pi epsilon naught. This is charge of an electron. Now next point, energy so next topic will be, that is energy of electron according to Rutherford model, hydrogen like atom. I will teach you tomorrow. Hope you understood the topic. Thank you.